Okay, let's get things started. Hello, everyone. Welcome to our API work group meeting. We pretty much have an open agenda today. I think the only request that I saw for agenda topics was to kind of get an update on what happened at the SmartNIC Summit. And there's a few of us who were on the call who were there. I see Venkat and thought I saw Marcia is also there. So there's a few of us who were at the SmartNIC Summit. Basically, the pre-meeting day, we were able to have a workshop which talked about OPI. We covered all the different areas, addressed several questions coming from the participants who had come to the pre-day, although there were, unfortunately, I think there were 3 parallel workshop streams going at the same time. So you got a mixture of attendees in the different workshops that were going on. So that was the unfortunate thing that happened at the SmartNIC Summit. The overall feedback that I saw in several of the things that I attended was that a lot of the presentations were talking about OPI, its importance, and how we can get a common mechanism by which we can do configuration and orchestration of IPUs, DPU type solutions. So that was the common theme. It was brought up in several keynotes and several different presentations across the discussions there. I don't know, Venkat or Marcia, if you have any additional things that you might want to add related to what you saw at the summit.
Yeah, definitely. Thanks for that. So I think there is not a single discussion that happened where people didn't say that, they need a common API. So every discussion ended up with, having a common infrastructure, common APIs, and as such. One thing I found, though, is that there's a good number of people there who still don't know about OPI and then the work that we do. So I think, most of us have went around, discussed, and tried to evangelize. So there was one more thing. I just lost my line of thought, but there's maybe it'll come back and I'll interrupt you again, Mark. So.
Sure, no problem. Any other observations, Marcia? Did you see any observations or?
No, I mean, nothing else besides Venkat, what you already mentioned.
Okay. Yeah, I think I found so too many early morning meetings. Not this one, but the previous ones. So one of the discussion was, how do we drive the adoption apart from the common APIs? A lot of suggestions, right? In OPI question answer session, as well as offline, what was requested is to start reusing what is already deployed. The key idea was that, if you accelerate or support what is already deployed, OPI will get, accepted and widely used. So I think that was, it may sound obvious ask, but the number of people who said that means that we really have to listen. We may really have to come up with a list of things that we have to synergize. Or somebody said, oh, OVS, OVN is a must for me. So all these musts that people have, maybe we need to write them down so that, in the beginning, I'm sure it'll look like a whole bunch of things and might look scary on how the hell do we even put all of them together. But I think listening to them would be useful, I think. Mark, I have an update on the discussions with the Microsoft and Dash team also. Do you want me to go ahead now?
Oh, yeah, go ahead.
Yeah, so we tried to, because Microsoft had a booth there and a presence. They had a parallel workshop. Unfortunately, I wish it was like one after another. So there would have been a lot more discussions. So there's a lot of presence. We tried to set up a meeting with all the OPI folks there, with Gerald, who is the main lead. Technical program lead, I think. And then Christina and his team, couple of engineers also were available. So we tried to set that up. We had VP of engineering, Liva there. Somehow we couldn't coordinate because there were so many of these parallel talks going on. But we did have enough corridor conversation, and I had a discussion also with them on how do we collaborate. In an earlier board, OPI board meeting, I took an action item to connect the two teams. So that's what I was following up with. While we couldn't do it there, they agreed to meet. So we will have, I will find a way to set up a meeting with at least the few guys from TSC and anyone interested from here with them. It was not a group to group, but I got time to meet with them. What I understood is that they're very much interested in collaborating, want to see if Sai, Sonic, Dash, how they are structuring the APIs, the layers, if it has significance to us and can be leveraged. I have a personal opinion that it can be leveraged. The behavioral model can be leveraged. There are a lot of things that we can leverage. That's just my personal opinion, but they had similar thoughts. One thing that from their side they seem to be interested in is Dash might have started with Microsoft use cases, but they're trying to keep it as generic as possible. But there's a narrower focus to start with, while they have broader visions. So they're making a lot more progress. But there are certain things that they are not actively working and then need help. And maybe that could form the basis of collaboration is the security. They have specific requirements. You can't get a better deployment than Azure, and then a few others if we can get into specifics there. So a suggestion was that maybe we should use security, and they're willing to define that for us. And then that could be the starting point for us to start putting some framework on how we collaborate. That's all I have, Mark.
Great, thanks, Venkat. Just to add to what you were saying about the list of musts, one of the topics that came up was it was really a question: how does OPI make operation easier? The reference was with respect to OVS and SDN, but I think in general, it's a general question that we have to ask ourselves is how does it make operation easier, and how does it make deployment easier? So I think if we start putting together a list of at least questions or musts that we need to take a look at least those two things need to be on there, because I did notice that in several of the topics that came up. Okay. Other things, is there anything else that we need to cover today? There was nothing on our agenda list. So do we have any PRs or project related things that we need to cover, discuss today? I'll ask Boris. Boris, do you have anything that we need to cover today? Usually you have something.
Yeah, so on the storage side, we split the backend APIs into multipathing, and we already applied it to all our storage bridges. So all of that work was completed. The next big thing for us is to figure out the more convenient way of do stack and rack of block devices on top of each other. Today we're using kind of hack mechanism to handle that from the back end to the middle end to the front end. So this is the next big thing for us. We also started to enable the security scanning of all our code repositories just to show security alerts on GitHub. So we're using several GitHub actions to show the security score and vulnerabilities. So that's been going.
That's the Open Source Security Foundation scan course?
Yeah.
Okay.
What next? We implemented the cryptographic keys for encryption. That's all been completed as well on the storage side. On networking side, so on networking side, we are working with Intel and Ericsson. We implemented already a good portion of EVPN gateway bridge. So basically, we spin up FRR for routing with VRFs, VNIs, bridges, and everything with VLANs and VXLANs. And we can show L3 networking end-to-end. Most of the code in Go language is already merged and submitted. So now we are in review cycle on gaps and where to take it forward. I see relatively small amount of participation on the specific repo. So if people are interested, feel free to jump in and join our efforts. The repo is on GitHub, publicly available with drawings of networking configuration, how it looks like, all the APIs and the Go language implementation with end-to-end integration testing and unit testing as well were added this week. So we have very good.
Hey, Boris.
Yeah.
Is it possible to, if there is no other topic for this meeting, to use this meeting a bit to explain the README of the VPN gateway bridge, because I'm afraid that I do not understand everything there. So you have a README and you have an image with the leaf and the spine switch there, and the different test cases that you try to run. So if you don't mind, can we just use this meeting now to explain it a bit?
Yes, feel free to.
Okay, would you like Boris to bring that image up? Will you share your screen, or should I do it?
Mark, will you be able to explain, because Venkat helped me doing that. I'm not a networking expert myself, so if Mark is okay explaining that, if not, we will try to I'll ask Venkat to join now and we'll see if he's able to join.
I'll see what I can do, but in the meantime, ask Venkat to join.
You can bring the image in the meantime.
Myself,
It
okay.
looks like Venkat's on the call, but he's not
Different.
speaking up.
Different Venkat.
Oh, sorry.
Yeah, one moment, I will try to do so.
Oh, okay, you got it before I got there. Okay.
Okay, so this is the image, Boris, right? And please explain the setup. What do you try to do here? So you have a host, right? And here on each leaf, it is your gateway, your EVPN gateway, we can say, where you have your VRFs, right? Okay. And what is the purpose of this spine switch? Just switching traffic, like VXLAN encapsulated traffic, nothing else, right?
Right, that's just a spine switch to do the switching between the leaves.
Okay. Okay.
if I understood it right, I went through
The
this a while
text-
back.
The text below try to explain the use cases. that
Yes.
L2
Yeah.
VXLANs, L3 VXLAN with asymmetric, and
Yeah, so VLAN 10, this one here stretch with VNI 10 to leaf 2. Okay, so this is an L2 VPN case, is that right? Because we're trying to ping on the same subnet, so there is no routing, and we use a VNI, so I guess this is an layer 2 VPN case.
Yeah.
Does that make okay?
Yep.
And on the layer 3 VXLAN asymmetric, we have VLAN 20 and VLAN 30. Where is the VLAN 30?
Yeah, I don't see it in his configuration. Oh wait, host 3 is on 30.
Host 3, this one?
Yeah, it's on 30, 30, 31.
Okay, and you.
I'm
Mhm.
trying to. Yeah, we need to get Venkat to explain that one for us. Because that was one that didn't make sense even to me.
I asked him to join, and we can always, catch him on Slack and do one off just with Dimitrios and you, Mark.
Yeah.
But anyways, I think that the goal, at least for us, is to simplify this a little bit because Dimitrios, what you showed previously and what I shared on the Slack,
Mhm.
this is where we want to go, right? This, I'm posting a link in the chat. Oh, I can share as well. That's
Yeah.
fine. So this is where we want, at least what you and Intel showed together. This is how the setup would look like. So basically we want to do a host with DPU and the test server being outside remotely, and we want to test L2 bridging between two pods, L3, routing between VLANs, routing in the same VLAN, and remote, which is VXLAN. I think those are the 3 use cases that we're targeting. Just make sure that we understand.
Yes. Yes, and maybe like 1/4 is just a, let's say a failed test case, failed successfully. Let's say where you try to ping from a pod that belongs that has a VLAN on a different VRF, and from the target that you try to ping. So if you have, for instance, a pod with a VLAN on VRF blue, and from that interface you try to ping a VLAN on the VRF green that belongs to the VRF green pod, then that should fail successfully. Let's say because we want to show that we have proper VRF separation.
Yeah.
So Venkat has joined now, guys, so we can get the questions from that.
Yeah. Okay.
Hi, Venkat.
Hey,
Dimitrios is asking about the diagram, so if you can kind of walk through a couple of questions that he had and explain the thinking here.
Yeah, it was some of the questions were around the 30-30.
Yeah,
VLAN.
this one.
oh, okay.
So I'm trying to understand. So VLAN 20 sits on this host, right?
Mhm.
And VLAN 30 sits on this host.
Right.
Here, host 3.
Yeah.
Okay. And what do you try to do this?
So basically that's an asymmetric IRB. So the request is coming from 20 network, and we are going doing the routing on leaf 1, and then going with 30 thing. So 30 VLAN. So basically there is a routing from VLAN 20 to VLAN 30.
The routing
happening at the
exists
leaf
on leaf 1.
Correct.
Yeah, but the problem is that I see here different VNIs. So you
that VNI 20 is not really is there. Basically we are not really using that VNI. So basically it's a VLAN. The packet is coming on VLAN 20 and then using the VLAN 30's VNI, which is VNI 30. That's all it is.
Okay, so VNI 20 doesn't exist, you mean?
Yeah, we don't need to. I mean, I just have configured the VNI 20, but it's not really required.
I mean, it's not about requirement or required or not. It is about if VLAN 20, VLAN 30 belong to the same VPN or not. So you have layer 3 VPNs per
Layer 3
VNI.
WEF, right?
So one layer 3 VPN should correspond to one VNI. So if VLAN 20 and VLAN 30 belongs to the same VPN, to the same layer 3 VPN, then
Yeah.
they need to have the same VNI as a VLAN VXLAN header. You cannot have like a VLAN 20 with VNI 20 and VLAN 30 with a VNI 30 and be able to ping. Then you don't have proper separation between the VPNs. That means that you can cross VPNs, which is bad. You don't want to do that. Did you get my point?
I'm not sure whether we can have different same VNI for both the VLANs.
You can. I mean, I can show you. Where is the image that you shared, Boris, before?
On the issues, if you go to the issues tab, it's the first improved POC diagram issue.
This
Yeah.
one? Okay.
Yeah.
So you can see here that
You can click on it to blow it up a little bit. Bigger.
even bigger.
Yeah, click on it. Yeah, it's a little small.
Is it okay now? Anyway,
Can you make it a little bit bigger?
it is really big for me. I mean, I
Really?
don't know.
Okay. Yeah, that's fine. I'll good. Yeah.
Now I cannot see it. Okay, now is it okay now?
Showing the same size. Maybe if we can click on it instead of zooming in, that will be maybe better. Anyway, I posted the link, Venkat. You can open it in a
Yeah,
link.
I've opened another window, so
Okay.
I see it big. So
Okay.
you can go ahead.
Would you like to share? You can share if you want, if it is better for you.
Oh yeah,
So
sure.
we can. Yeah, thanks.
Do you see it?
Yes. Okay. So you see this VF4 interface in the pod access.
Yeah.
So that interface belongs to VLAN 22, right?
Okay.
And also try and from that interface we try to ping the VF5 interface on VLAN 20. So because those both VLANs belong to the same VRF, which means on the same layer 3 VPN, they are able to get routed and ping each other.
Yeah, you're right. That's what we are doing between VLAN 20 and 30.
Yeah, but they don't belong to the same VRF because you have different VNIs there.
Okay, it belongs to the same VRF, which is blue, I guess. But
Yes,
VNI,
I mean,
we can correct it. I mean, that does not matter. So, yeah.
so it's like what you try to do. Can you see? I mean, let's assume that on the left-hand side, the VRF blue, okay, it
Yeah.
is VNI 20,
Yeah.
okay, and on
Yeah.
the right-hand side, the VRF green, it's VNI 30. It's like you're trying to ping from VRF blue to VRF green. That should not be allowed because they are in
Oh,
different VNIs.
Okay. Let me double check. I don't think we are going across VRFs. Let me make sure.
Yeah, I mean, you can ping across VLANs, but they must belong to the same VRF, and that means to the same VNI, layer 3 VNI. Otherwise, should not work.
1 second. Let me see. Yeah, can you share the other diagram that we have? You don't mind?
Yes. Let me find it again. Can you see?
Yeah, so if you see here, right, VLAN 20 and 30 are part of the same VRF, which is blue, and the VNI numbers are different, but that can be fixed. If you want same number, we can put it.
They should not be different because the VNI, at least is my understanding, the VNI identifies the VPN, right? So if those VLANs belongs to the same layer 3
No,
VPN,
no, I don't think so. I don't think VNI identifies the VPN. So VNI is per VLAN. The L3 VNI is something different. You can have one dedicated VLAN for a L3 VNI, and that's what we have in other use case, L3 VXLAN symmetric IRB. I can give you some reference. I mean, if you want, how things are done with
yes,
the
please,
L3.
because I know
yeah.
the only thing that I know is that the VNI is per VRF. So
No, VNI per VRF is L3 VNI case.
yes.
Yeah, so VNI will be for VLAN. That's for L2 VXLAN, and L3 VXLAN, there will be an IP on that particular VLAN. So that's what we are trying to do in the second use case.
It's still not clear to me.
Yeah, the third one is basically the VRF case. So we will associate VNI to a VRF, the VPN that you are talking about.
Okay.
For whatever be the case, we will associate VNI to a VLAN, and in case of L3 VNI, the VLAN will not have an IP. That's what we use for VLAN 100, 101, and 102. So all those VLANs will not have an IP.
I mean, I can understand that for the layer 2 VXLAN, okay, you have a VNI per VLAN, of
Yes.
course, because it's
Yes.
layer 2.
Yes.
And for the layer 3 VXLAN symmetric, you need to have like a VNI per VRF, right?
Dmitry,
But
you can see the chat. I think Gurpit is trying to explain as well. You can unmute yourself, Gurpit, if you want.
Yeah, guys, so you may have seen the messages. I'm basically agreeing with Venkat here as well. There's a difference between the L2 VNI and L3 VNI there, right? So the L3 VNI is unique for each VRF, but not for L2 VNI. And I'm assuming that Venkat, you're referring to L2 VNI here, right?
Yeah.
Yeah. Okay.
I mean, the layer 2 VNI is the first case, is the layer 2 VXLAN, right? This is correct.
Yeah.
And the third case, which I believe is the VNI per VRF, is the third case, the layer 3 VXLAN symmetric. So the one that I don't understand is the middle one, the layer 3 VXLAN asymmetric.
Yeah. Yeah, asymmetric. Let me give you some, I don't know, some references for you.
And while you're searching, Venkat, I do agree that if there are questions, I think that means it's not explained properly. So maybe we can take an action item to just add a little bit more text explanation and show different flows. Maybe this picture with the text below it is not good enough explaining the use case.
Yeah, okay, sure.
Okay, then are you gonna share something, or are you gonna come with a better image so I can explain, I can understand what we are trying to do? I don't know. Did you share something?
Yeah, let me give you some references, and I don't know if and then I'll add some details to
Okay.
make it clear. Yeah.
Okay. Okay. Thanks.
Sure.
And Venkat, Dmitris, what we started to discuss in chat, I think Venkat Uday also mentioned that we can probably a little bit simplify this diagram. Maybe we don't need a leaf 1, leaf 2, B leaf, and spine. We can a little bit simplify the diagram to have less components. What do you think?
Yeah, sure. I mean, it's like full-blown diagram. I try to cover as much as possible, all cases. Yeah, with various, typical topology, how it will be, right? So if you want to simplify it, yeah, we can go ahead for it.
Demetrius, what do you think? You want to go
Yes,
with
yes, I think
known
it's
diagram, or you want to still simplify it because it has values to having the entire networking, spun up and showing how to do all the use cases.
I mean, when you spin up the VPN gateway bridge example that you have, when you spin up the Docker containers, okay, do they represent what do you have right now on the diagram, or it's completely different topology?
What we have with the containers is representing the Venkat's diagram, one-to-one.
Okay, okay. Then maybe we can start with explaining a bit more the diagram, and to at least understand it first, and then I can tell you if we can simplify it or not. Is
You
that
still have
okay?
questions? We have time. Venkat can go through the rest of the diagram if you still have questions. In addition to the references and the explanation he will put on the diagram itself, or maybe text. If we can use this time to ask online again, if you can reshare and then ask Venkat.
Yeah, I mean, I don't get the second the layer 3 VXLAN asymmetric case. So that if Venkat can explain to me, that is this one.
Okay, so here, so basically we use VLANs 100, 101, and 102.
You could use annotations, Venkat, to draw if you want on top of the screen.
Yeah, okay. Let me see if I can. I don't see annotations.
Mark, can you enable annotations? I think you
I'm
use.
looking. Looking for annotations. Yeah, unfortunately, I don't see it in any of the choices here.
We can open it in Draw.io and then maybe do
Yeah,
one.
I would do it that way. It might be quicker. So right now I don't see annotations in our setup. Okay, do you want to open it in Draw.io?
Or drive.
Yeah,
Sure.
and share it that way. That way you can annotate on it.
Let me see. I mean, we can do whiteboard. If I don't know if
What?
that's.
You can do whiteboard if that works. Either way.
You can see the whiteboard, right?
Yep, it's coming up.
Yes.
Okay. So basically what we are doing is, so we have 3 VRFs. So each VRF associated with the L3 VNI, and then with the L3 VNI, we're just pinging from the host. So I think 555, 666, and 777 IPs. So that, that's what, Demetrius said, like the VRF mapped to the VPN, and then there's a dedicated VNI for it. So host, it's like you have a host here, and then that host talks to. I'm just simulating, multiple tenants here. The VRF yellow, blue, green, and then it's connect to the leaf one. Say this is leaf one, and then there is a border leaf here, and then there's a internet. You can say there's an internet. Yeah. So in reality, you will have 3 tenants. So you can say this is like blue, green, yellow. Okay, connected to the leaf. Yeah, something like this. You will have you can just have, let's say, spine here or something. So this is a fabric basically.
Yes. Okay.
And there's a internet. So each the traffic coming from the blue VPN will basically go to that blue VRF, and then there is a VRF, the VPN, sorry, the VNI are defined for that particular VRF, and then that the packet, if you capture, you will see those VPN blue VPN tenant traffic is taking that particular VNI to reach all the way to the blue border leaf, and then it will be decapsulated and the traffic will reach the internet.
Yes.
Yeah. This whole thing is fabric. Yeah. Something like this. So there is a, in case of symmetric, there is a routing happening every place. Unlike asymmetric, routing happening only at the ingress, and then switching happening. But whereas in symmetric case, routing is happening every leaf one, and border leaf, every leaves. That's a difference, symmetric and asymmetric. So in case of asymmetric, when you want to switch traffic, between VLANs, every VLAN should be stretched. In our case, VLAN 20 and 30, the traffic is increasing on VLAN 20, and in order to go to 30 network, the VLAN 30 should be present on all leaf switches. Otherwise, asymmetric IRB won't work. Whereas here in the symmetric, since we are operating on the L3 VNI, you don't need to stretch, the other VLANs for routing. So because we take the L3 VNI, which is independent of any VLANs, L2 VNIs. So that's the difference.
So okay. So can you please explain to me the asymmetric case, how you stretch that VLAN that you say? So let's
basically,
assume
okay, you know what is L2 VXLAN, right? So where you have a VLAN with VNI, and you will not have any IP on that VLAN, right? When the host sends the request, let's say, let's see, I can put something here. Okay, this is the host one, and this is on VLAN 10. Okay, so here I will have VLAN 10 created on leaf 1, And then the VLAN 10 will have the mapping with the VNI 10, let's say. So when the packet comes to this leaf 1, it does the lookup because there's no MAC. It does the broadcasting, flooding on all members of the VLAN. The one of the member of the VLAN 10 is the VXLAN tunnel. So with the VXLAN tunnel, it goes all the way to other leaves wherever you have BGP, EVPN distributed tunnels. It goes all the way in all places, at least in case of hidden replication. And then the other node, basically, let's say you have leaf 2 here, and say there is a this is host 2, and it's also VLAN 10.
Yes, okay. So if you try to ping from host 1 to host 2,
Yeah.
They're on the same VLAN, so
Yes.
you use a layer 2 VPN, layer 2
Yes.
VXLAN.
Yes.
And yeah, okay, that is clear.
Yeah. In case of asymmetric, so basically, let's say that's where the another host comes into the picture. So say this is VLAN 20, and this is VLAN 30. So in case of asymmetric, to do the routing from VLAN 20 to VLAN 30, you need to stretch this VLAN 30 in all leaves, basically. So you need to have here, you need to have VLAN 20 and VLAN 30 as well. So VLAN 20 and VLAN 30. So when the packet comes from the host 3 on VLAN 20 and in the destination is, let's say, 30 network.
Yes.
Let's say this is 30.1 and the traffic is coming from 20.1. And I have the Anycast gateway, let's say 20.100 here. And then on VLAN 30, we have 30.100. These are all Anycast gateways. So basically, when the packet comes to the default gateway, which is 20.100, VLAN 20 is MAC, and then here leaf 1 does the routing basically from VLAN 20 to VLAN 30, and then it takes the VLAN 30 VNI. Let's say VLAN VNI 30, and then it goes all the way to the leaf 2, and then it does the L2 VXLAN decapsulation, and then reach the packet onto host 4. So that's this is asymmetric IRB basically.
Okay, okay. So the packet goes, you want, okay. One moment to understand. And why you want to do that? Why you just do not do routing? Why do you want to have like this VLAN, this layer 2 VPN thing That is, I don't know how that's working.
It's not like
exactly.
everybody supports. It's like predominantly most vendors support symmetric IRB, but asymmetric IRB is also a use case. Some vendors
Mhm.
prefer, supporting both, but not everybody supports it. Just
Yeah,
for the completeness sake, I added all possible 3 cases in the topology, but asymmetric is not everybody supports. Symmetric is because it's scalable. You don't need to stretch VLAN 30. Let's say if I want to reach to other network, I don't want, put additional VLAN 30 on every other leaves, which is, too much to add to my topology, right? So that's why people prefer L3 VNI.
okay. So just to understand, from host 3,
Mhm.
the traffic will go without encapsulation to leaf 1, right?
Yes, yes,
And there you will have a routing inside
yes,
leaf 1, right?
yes.
And it will use the
After that, it's all L2 VXLAN.
and after that you will get a layer 2 VNI and will
Yeah,
go to the host 4 to leaf 2 and host 4.
that's correct. Yes.
Okay. Okay. We haven't. We don't have this use case in the VPN gateway POC
Right, right, right.
right now. We have only symmetric and layer 3. We have only the routing case with
Yeah,
layer 3 VNIs
yeah,
and the layer 2 VNI, but not
yeah.
this asymmetric thing.
Yes,
So this is not tested with our API.
right.
Just so I don't know if we should put it under EVPN gateway bridge or we should leave it out for now.
Okay. Yeah, I mean, this is definitely a use case for few. It's not like widely adopted one. So you could read a lot of documentation on pros and cons with asymmetric IRB, but symmetric is the one people prefer. So in
Yeah.
case of if you want to have so basically if you want to use symmetric IRB here, what happens is you don't need let's say the same case. I will have VLAN 100 and with L3 VNI. So the same thing, I will have L3 VNI here. The L3 VNI, there is no member ports basically of L3 VNI other than the the VNI, other than the member ports of the tunnel. So only the tunnel will be the member port of the VLAN 100 and no other members. Whereas in other L2 VXLAN case, there will be downstream ports and tunnels and everything will be members. But L3 VNI case, just VLAN 100 is the member. VLAN tunnel is the member for VLAN 100 here. So here VLAN 100 will be there. You are not stretching to reach the other node. You don't have every VLAN stretched to leaf 1. So you just have one dedicated VLAN for this purpose, and then whenever any traffic coming onto leaf 1, that particular VRF, it does the lookup, and then through this type 5 route, you would have got all the routes from the border leaf or other leaves, and then it does the route lookup and takes that particular L3 VLI tunnel to reach the other node.
Yes. Yes.
Yeah. That's the very common use case. A lot of people support that asymmetric IRB case. That's what we're trying to do. So the asymmetric is something, we wanted to, for the completeness sake, we wanted to cover all 3 scenarios. I just added it, but if it's not required, maybe we can say it's not supported at this point. Yeah.
Yeah. So in the symmetric case, so the border leaf and the leaf one should be on the same layer 3 VNI, right?
Mhm.
And and the traffic, I mean, in that case, I don't think we care about the VLANs that we have in between the 2 leaf switches, the leaf 1 and border leaf, because the traffic will be completely routed, right?
That's correct. That's correct. Yes.
So we can have host 3 VLAN 20 traffic arriving in the leaf 1, and then because it will be routed, when maybe we try to ping like an interface on the border leaf, which is
Right.
VLAN 500,
Right.
right? Because we don't care, it's completely routed. And the only common thing that they have is that they belong to the same layer 3 VPN.
That's correct.
Yeah. Okay. So this VLAN 100 layer 3 VNI, maybe we can remove it from there. Let's assume that we try to only one, because now it's a bit confusing, right?
I think
Why
once, if you understand, Dimitrios, what's going on now, I think we can leave it, not remove it, but just focus on 2 use cases that you had in mind first. We can
Yeah,
still
it's untested. It's untested, that asymmetric use
Yeah.
case. So, and I don't think
Untested
we
yet,
support
but
it right. Yeah,
it's untested yet, but we'll get there. Probably.
yeah, probably. I don't know.
I prefer not to, remove and then re-add it back. If we understand the use case is valid, maybe it's untested or low priority first. That's fine with me.
Yeah, and maybe if we can have like a better documentation under that image, because like a better explanation, because it's not really clear what from where you try to ping to where and stuff like that.
Okay.
Yeah, maybe more color coding, or maybe split the
Yeah,
picture into a couple
yeah.
of pictures. Like Dimitrios, you can make suggestions, right? If you think that what could, or you can take a stab at it, right? All the pictures that we have are from Draw.io editable. You can just open them if you think that you
Mhm.
can improve.
Okay.
By all means, go ahead. Yeah.
Okay.
And Venkat, you also give it a try. So
Yeah, sure.
I agree, it's not 100% clear from
Yeah.
without your detailed explanation.
Yeah, no, that was a good explanation, Venkat. Thank you, because even I wasn't sure how that one was working. So.
Yeah. Okay, sure.
All right, we got 4 more minutes. Any other questions on this, or we can take it up in Slack?
So just to make sure that everyone is on the same page, so this is a picture that we have, and in Docker Compose, this is exactly what we spin up as a containers. So they have container for leaf 1, for leaf 2, border leaf, for spine. We have all these containers up and running, sending gRPC APIs, and today doing the Linux kernel networking translation. That's clear, Dimitrios and others?
Yes. Yes.
Okay. And as we go with implementation, we're just replacing the static configuration now with gRPC protobufs and translating them to Netlink. Most of the work was already done, and we are just finishing more and more commands and more options described in the protobufs.
Okay. Well, thanks everyone. There's 3 minutes left, so we'll give that at least a little bit of time back to you so you get a chance for a small break before your next meetings.
Venkat, thank you for joining. Thank you for your explanation.
Yeah, no
Yeah,
problem, Boris. Yeah.
Thank you very much.
Yeah. Thank you. Thanks, everyone.
Right, thanks everyone.